Hello, everyone, and very good evening. Today, we are back again with another session of OT Security Huddle, this time again on automotive security. Since we are in the era of connected cars and the technology for automotive vehicles is increasing by the day, this also brings the cyber security in perspective. So, joining me again today is Arun. Arun is an automotive security expert. You have seen him earlier on the huddle. Today, we have chosen a more practically oriented topic, which is security for CANBUS. We have put up a lot of content to give you practical insights on the connected vehicles and also the possibilities of attacking a CANBUS network. So, I welcome you, Arun. Thanks for taking time for putting up this deck. And I know we have been trying to chase you out of your meetings and your schedules, but finally we are here with slight delay. So thank you for putting this up and agreeing to do this for the audience online. Yep.
Thank you so much, Shiv.
Yeah. Okay. So without further ado, I will hand over to you because we are slightly tight in the time. We already lost some time, and since it's a weekday, I think people will be also squeezed in terms of their availability. So before we begin, just a formal disclaimer that whatever we are sharing is out of our personal interest and nothing to be construed as the official opinion of the organization we are associated with. For you, Arun, this is not true because you can say that the opinion is the organization that you are running for. Okay, so we will be discussing a bit about CANBUS, the communication networks on the connected cars, the tools that can be used to attack the CANBUS and the connected car network. And finally, we will spare some time for actually showing you instrument cluster and then attacking a CANBUS network on the car. If time left, we will still be taking some questions. Otherwise, I think this session is very jam-packed today. So over to you, Arun, for the exciting discussion. And welcome again, and thank you for agreeing to do this.
Yes, thank you, Shiv. Thank you. I hope I'm audible from my side clearly.
Audible, yeah, but slight noise from the background. If you can just turn on noise cancellation, that would be
Sure,
really
sure, sure, sure. Okay, now?
yeah.
Yeah. Okay. Okay. Today we are going to understand and see some practical approach how we can, take a, advantage of vulnerabilities in the canvas itself. Some of vulnerabilities can be a protocol level. Some of vulnerabilities can be design level. It's depend on the the developer how they go with the ECU and everything. And definitely, if time permits, we will show you the real time attacks on the one of the ECU, and we will discuss more in that case. So I want to go in a story mode actually, so everyone can understand what how we are going further and where we need to have the knowledge itself. So you can visualize the entire things actually in how we can proceed further for the automotive penetration testing in the terms of Canvas. Let's say the story start with the scope. So we are working in the cybersecurity and suddenly we get the scope. Not suddenly, it's a part of the work as well, and we understand what exactly the scope actually. There are two kind of scope into comes into the picture, like vehicle level and component level. So when it vehicle level, that means it literally we are talking about the attacks. We need to perform attacks on the vehicle itself, on the external. But when we talk about vehicle level, some of the attacks we need to perform physically. For example, OBD2. So OBD2 is nothing physical. Physical, we need to know. We need to have access. So after understanding the entire canvas, what are those vulnerability related to CANBUS in vehicle network, in vehicle IV and in vehicle network. Then we go further for the remote attacks, and in the remote attacks we need to have vulnerability itself. So these are the things comes into the picture. What happen when it's a component level? Okay, in the component level, that means the client will give you the ECU in that case, and in the ECU itself, uh, you know we, they give the simulator. It just depending on the client to client. If they give the simulator which send CANBUS message to particular targeted ECU, and in that case it would be a the component level scope. So we know the scope now. So here in that case we are going to work, or the scope would be the component level. So client give you the component, that is nothing but the ECU, one of the ECU, and the scope would be a black box, not a white box. White box comes into the picture, you have to talk to the client, you get the information about the blocks and details of ECU, and maybe they give you the Tara as well. Once you have the Tara, you go with the entire attack vectors what they mentioned, and the some of the threats are related to attack vector which is not included in the Tara. You have to perform that as well. And in the report you have to give the stresses, I mean to say, like you have to give the uh, IDs, Tara of IDs or identification numbers, which is mentioned in the Tara report itself. We have to trace down the with the report as well. That would be the things in the white box. Maybe they also give you the spec books in that specification book related to ECU. What is the specification books? In the specification book they mention about the entire architecture, block diagram of the ECU, and what are those arbitration ID uh, for the event. I mean to say the functions in that case in the vehicle itself, like brake. In that case it's a very important function in the vehicle itself. Like you can say the speed of the entire vehicle itself. It will going to show on the instrument cluster. When I say instrument cluster, nothing but is a speedometer in other language, we can say that. So these are the temperature function, speed. These are the different kind of sensor. They get the data, and based on that event it shows actually. So this is mentioned in the specification books. That means ID and what kind of data it goes, and depending on that, it mentions every detail. Every detail, which is very confidential and very important, top secret kind of documents, you mean to say. So if it is white box, definitely they will give you the spec books. So here in the scenario we got the black box testing. In that case we don't know about anything. Okay, that is the thing. So let's go some details when we start infotainment canvas communication testing. So let's say we are come from very cybersecurity perspective, or like traditional cybersecurity, or let's say we are coming from the OT or traditional cybersecurity, such as the web application network in that case. So what is the internal and external communication in that case? Let's go further. So next slide. Okay, I will do that.
Yeah, just one
So what?
question there, Arun. You mentioned white box and you mentioned Tara. So you
Mhm.
basically mean the threat and risk analysis for the device, right?
Absolutely correct.
Yeah.
Absolutely correct. Yeah.
Okay.
So it's depend on the client itself. If they
Hmm.
are ready to go with the white box approach, and they are ready to go with sharing the Tara itself, that would be the good. So specifically what happened, when the pen tester are very good in that, so their testing approach would be a better than the Tara. That would
Hmm.
happen sometime.
Hmm. Yeah.
So that's how it is in that case. So it's depend
Right.
on the client. And let's say, as I said, we are coming from the not automotive background, but we are coming from the another background, but cybersecurity. So in
Yeah.
that case, we should understand what is internal and external communication. Before that, we have to also understand what is a system, hardware, and software. These are the departments in any OEM, tier one supplier, OEM, or any manufacturing plant. So, what exactly the system would be? The system department always focus on the system design and integration of components. His responsibility ensuring that all vehicle system work harmoniously together. So this is the work of system design. The guys who work in the system design, they know entire architecture. When we talk about
Yeah.
architecture, is nothing architecture in that case. And they always work very closely with hardware department and software department. So it's very important to understand those things. When you go for the cybersecurity testing, you always talk to system and hardware and software design, software department persons. So hardware department consists with the physical components and electronics used in the vehicle itself. Let's say you have PCB board of ECU, and whatever you saw, whatever you see is, in that case, like the microcontroller, what kind of microcontroller, which component they have, and all registers and everything. So everything is talked, handled by the hardware department, and every component, the components on the PCB board should be compliance with the automotive standards. There are different kind of standards are in the automotive, related to safety, related to component, everything in that case. Even if you see the seat in the automotive industry, where the driver or rear passenger, they sit on that seat should be compliant with the automotive standards as well. So these are the things in that case. So in the software develops the software that controls various vehicle functions and features, such as ADAS. ADAS is like advanced driver assistance systems, where they have different kind of features. ADAS 1, 2, 3, 4, 5, depending on the automations. Till 4, ADAS level 4, the entire things are autonomous in that case. You don't need to sit on the driver's seat. Actually, in that case, you are sitting in the passenger, and automatically the entire depending on the sensor which the vehicle have and surroundings, it take the decision, and based on that decision, the vehicle runs. So in
But
that
then
case,
I think there would
yeah,
not be driver's seat at all in those vehicles. This
absolutely.
will-
In
yeah,
I think so. 2027, 2028, you will see those kind of vehicles on the road, actually.
yeah, yeah,
And definitely, there are some areas in the US, European region. I cannot recollect that. In that case, I saw the videos, right? So one of the people, they booked the autonomous vehicle,
yeah,
and this driver was not there, but the
yeah,
vehicle in such a way that I
yeah,
think so vehicle from Jaguar or any European company in that case.
yeah,
And the sensors are attached from the top level, side level,
yeah.
and based on that it drives, so you know where to go. So
Yes.
your vehicle, autonomous vehicle, knows the destination. So there are different ways. So in future, they for transportation, they are using autonomous level 4. So in future, definitely
Mhm.
people go for autonomous for day to day life in that
Yeah,
case.
yeah,
So this is how exactly it is. So the software department makes sure that features run very precisely in that case. If something happen in the software itself, it creates a havoc on the road itself. So very crucial way they design, they code the software, they code the firmware in that case. So designing embedded software for engine control, in that case VCU, vehicle control unit,
mhm,
infotainment system, and safety features. Focuses on the cybersecurity to protect vehicle from digital threats. These are the peoples who mitigate those vulnerability which are going to find which are we are going to find it in the assessment itself.
yeah,
If the hardware get damaged, then hardware department comes into the picture. If entire architecture get affected and there is a problem, the system software and department comes into the picture, and they try to work on target side architecture. So when I say target side architecture is nothing but it apply in various sector, like not in the automotive itself, but it in the
Mm-hmm.
OT environment and IT environment itself. So it's very crucial aspect in that case. Okay, so as I said, system, hardware, and software department are very essential things, and they have to work closely, hand to hand. Then the entire vehicle works actually seemingly.
Yeah.
So what are the external communication? If you see on the diagram, that particular photo, we have a lot of external and internal communications in the smart vehicle itself. It start from tire pressure monitoring system to regenerative brake. I'm talking about from right to left, okay, in that case. And the digital turn signal, electronic toll collection, lane correction is another kind of ADAS feature. Battery management systems, BMS particularly, it's come with electrical vehicle in that case. And DSRC again, V2X, the communication, so it's like a dedicated short range communication in that case. Cable environment control, voice data communication. Nowadays you can see voice communication, right? If you have
Yeah.
Mercedes or something, hey Mercedes, open the door, or any command you can pass on, it triggers that particular event. So these are nothing but the external and internal communication. So depending on the feature, if we come with the help of the scope, would be in that case, it's a vehicle level. So these are the aspect comes into the picture, and these are the threat maps in that case. So if you go for Tara on the vehicle level, so they will see these features as assets in that case, and based on that asset they derive the entire risk, and derive the entire risk, they calculate the risk and the impact analysis, and based on that it come up with a cyber security concept and requirement itself. And the entire TARA report goes to testing and validation program, nothing but it comes into the cybersecurity testing as a penetration tester, and the cycle goes on, right? So the pen tester come up with the vulnerabilities or new vulnerabilities, it can get added in the Tara itself, and it get mature and mature while testing goes on. So these are the things we need to consider in that case. So if you go any kind of market analysis in that case, so V2V is technology emerging in that case. So V2V, V2N, V2N is nothing but vehicle to network, vehicle to infrastructure, and nowadays we are going into V2G, vehicle to grid.
Yeah.
So what is exactly the vehicle to grid? Nothing but you are connecting the car with your home, and home is connected with what? The grid. So something havoc happen at your place or in the grid. So it would be reversible. So your car becomes the power source for your home or for your grid in the future. So they will draw the power from the electric vehicle in that case. So this is kind of crazy, right? That's crazy technologies coming into the picture nowadays. So it's called as V2G. So something happened or your car got compromised and it's sending malicious activity or doing some malicious activity in the future can affect the entire grid as well. So this is kind of cat and mouse game in that case. So one of them get compromised, they will affect each other, or either it's a hypothetical thing, and it can be possible as well in that case. So
Yeah.
grid get contaminated, or in that case a malicious activity can possibly they can affect to the vehicle itself, or vehicle can affect to grid itself. So these are the technologies getting emerged. Telematic is one of the things we can see from long time in that case. So it's kind of it gives the GPS coordinates of the entire vehicle, nothing but FMS, the fleet management systems up to your entire vehicle. It also gives the remote services. We can turn and turn off the entire communication with the help of your mobile app. Nothing but your telematic talk to your cloud, and from cloud to your the mobile application, and vice versa. Even we can see infotainment system. So ICE is nothing but in-car infotainment. If you talk about infotainment, or rather, ICE is, we call it as a powertrain. In that case, it's a internal combustion systems, or BVV is battery vehicle. We can say this is the powertrain. So in that case, ICE is nothing but in-car entertainment. In that case, your rear seats and the driver seat have infotainment which can be controllable. Your massage ECU, your seat and everything, and your infotainment system, like features such as audio, video, and these kind of entertainment system. The features can be controlled in the ICE. Navigation systems, again, in the navigation, they are third party application. They can use, they can integrate the application source or integrate the services in the infotainment system. And communications. So uh, in the communication, infotainment systems comes with nowadays telematics, and telematics gives the internet, right? So it's connected with the internet system in that case. So you can use as a wi-fi hotspot, and you can further use for OTA, over the air updates. So these are the things comes into the picture. This is kind of analysis over here. So okay, we know that what is the internal and outer external communication in that case. So we got the project, we understand the scope and everything. Now have to understand what exactly we understood, that something communication used on the some communication used on the ECU. So what exactly? So then we found that there is a CANBUS communication. So what is CANBUS communication in that case? So CANBUS communication is message based or message oriented communication approach, where ECU transmit and receive messages containing data packets. So what exactly the ECU? Nothing but electronic control unit, engine control unit. There are different terminologies. When you talk about the engine, they call it as engine control unit. When we talk about this system in generic, related to a lot of sensors, actuators, which is controlled by some control unit, nothing but we call it as a ECU, electronic control unit. So being it's a message oriented, mm, you know, communication. So in that case, so what exactly happened in the network itself? So it transmit or it broadcasts the entire message in the network itself. So whatever the message, the arbitration ID, nothing but we'll come to that. What exactly arbitration ID intended to the particular issue, it accept. Otherwise, it ignores. So it's a broadcasting nature in the vehicle network. So what happened? If you part of the network, you will understand the communication itself. Same way, Modbus TCP, right? So it's a clear text thing, and it's based on master slave kind of protocol. So you can intercept that communication, or you understand in communication. So if I create compare with the CANBUS is again clear text in that case, and it's a bus. So if you are in the bus, or rather you can say in the network, vehicle network, or in the you're between two ECUs, you can intercept communication easily. That is the nature of the CANBUS communication. So what exactly the frame in that case? So if you see SOF, that's the start of the frame, and we have ID. So entire CANBUS, it's launched in 1987 by Bosch. Bosch created CANBUS, and after that, in 1989, they come up with the two protocols. Not two protocols, two type of protocols in the CANBUS itself. That is CANBUS 1.0 and 2.0. In 2.0, they have CANBUS 2.0A and 2.0B. So what is the difference between CANBUS 2.0A and 2.0B? It's arbitration ID. So 2.0A is 11-bit identifier. You can see on the screen, and 2.0B is nothing but 29-bit arbitration ID. So this is a huge thing in that case. And following that, they have RTR, and then control is nothing but entire DLC, data length code. And after that, this CANBUS frame, nothing but data, which is 64 bit in that case, and CRC, and then followed by acknowledge and end of the frame. Next. So in that case, if you see clearly over here, so arbitration ID made up of consists of 9 bit in that case, and the data length code DLC and data frame and CRC and end of the frame. So entire testing now based on the entire framework. So now we understand the what exactly the arbitration ID. First, this CAN bus message works on the two-wire communication, CAN high and CAN low. If you see on the screen, CAN high and CAN low, you can see easily, right? So these are nothing but
Yeah.
differential signals. Okay, so in that case, if you part of that two-wire communication, nothing but CAN bus. In that case, you're part of the network. So nothing but what happened, you are acts as a your hardware device acts as a ECU in that case, and you listen all the information, or we call it as a eavesdrop attack or sniffing in that case. So you understand the entire communication, whatever floating in between the two devices or other two ECUs or in the vehicle network itself. Okay. So these are the information related to the canvas frame. So start of the frame, identifier, then uh, stuffing bit in that case, remote transmission RTR in that case, remote transmission request, identifier, receive. Received bit, data link code, data frame, CRC identifier, and so on. So in that case, if you search, it's definitely these are the slides what we took pictures is from the Wikipedia. So if you search canvas what exactly it is, you will come to know in detail of the entire canvas related to thing. Okay. So these are the structure usually you can see in the canvas communication. There are different kind of canvas. Now automotive Ethernet comes into the picture, canvas FD, and many things. And this is what we talk about the canvas which are being used. There are other communication in the automotive protocol, such as the FlexRay, LIN protocol, canvas FD. So in the architecture, uh, electrical and electronic architecture, in that case there are different kind of ECUs work together, and architecture can be a different kind of centralized architecture, decentralized architecture, waterfall architecture. Now the trend is going on about the software defined vehicle. So entire architecture based on the waterfall architecture, which is controlled by centralized ECU, and these entire things getting updated with the help of cloud. Let's say you have a car and your car works on level 2 ADAS, and you want level 3. Either you can go and buy a new car, right? So the manufacturers manufacture the entire car with a level 2. I'm giving an example, right? And so again there is a hardware, software, and system person comes into the picture, and they spend entire 2 to 3 years, 4 years, and come up with a new architecture and new vehicle itself, new model itself, which works on the level 3. So software defined says that you have the hardware, everything, right, on the car itself. We will give you the software, we will give you the update on the software, that becomes your level 2 to level 3. So no need to manufacture another model which works on level 3, right? So this is how the software defined vehicle works nowadays. So entire things, the entire car driven by the software. So you can imagine something happen in the software itself, or something at the time of uh, software update. If you send malicious software, and if executes on the on the
Yeah.
vehicle itself, it can create chaos. It's supposed should not happen actually. But the great researcher or the white hat hacker in that case, if they reverse engineer entire software mechanism or entire sums in that case or software update in that case, and they try to bypass primary and secondary bootloader mechanism, the signing mechanism, definitely he can change into the ECU itself, and that can trigger a chaos in on the vehicle itself. That's a lot of security mechanism comes into the picture to avoid those kind of attacks in that case. So yes, so software defined vehicle is the future now. So your entire vehicle becomes subscription based vehicle. So in that case, whatever you have, suppose for example, this is not the way actually, but for example, I'm giving example like your infotainment supports only Wi-Fi but not Bluetooth, and you ask, you register like uh, register like you need a Bluetooth in the infotainment system, and the OEM send the update, software update, and you have no Bluetooth on the infotainment system. I'm giving just example. So that's how is going to be work the software defined based vehicle in the future itself. So okay, we understand the entire scope and what are the external and internal communication of vehicle, and we also understand the what kind of communication getting work or getting used in the vehicle or between two ECUs, right? That is CANBUS, and we understand the CANBUS. Okay, so we got the project, the scope, we understood scope, that is black box in that case, and we understand the external and internal communication, and then we figure out what communication, that is the CANBUS. Now the question is, what are the tools are required to perform penetration testing, or rather you can say car hacking or CANBUS hacking, whatever you call it, right? So there are two types of tools are there which is work together actually. So it's a hardware based tool and the software based tool. So what are these things actually? When we talk about the hardware based tools, nothing but we have PCB, small breakout board or small PCB board or anything which have CAN trans receiver. So what is exactly the CAN trans receiver? So CAN trans receiver which have a capability to receive, transmit and receive the messages. So these CAN trans receiver may be from microchip or any kind of manufacturers, and they it designed in such a way that we can control with the help of the dedicated software or libraries in the form of Python, in the form of the C programming language. So that is the this tool is called as USB tin. In that case, it costs around 35 euro to 40 euro. And if you search USB tin on the Google, so you'll get the information. And I don't know whether this author is selling right now. I don't know exactly, but if you connect with him, and definitely it's open source, you can create your own device because he shares schematics as well, the PCB schematics, and you have to they share also BOM, bill of material, and based on that you can create your own device. So there is a Cantac, I believe so. It's from the Chris Ivan, that author, and this thing is cost around 90 to $100 in that case. It supports. It have the DB9 cable and Ethernet as well, I believe so. There is nothing but there is other called as can hack. It's from very good person in the hardware hacking, or sorry, the automotive hackers, and he designed the can hack device, and which supports many attacks vectors in that chipset. So nothing but he come up with the MCP that is from the chips, and integrated with the Pico can. In that case, Pico Raspberry Pico, which
Yeah.
can integrate with your micro Python, and you can definitely control that entire communication segment in that case. Okay, and there is a CAN triple, which is very old, I believe so. There are some other versions as well in the market. So CAN triple is another kind of device where you can use OBD9, DB9 cable to OBD2 kind of converter you can use over here. There is another called as interpret device. They have value can 3, value can 4 in the market. It's cost around 300 to $400. So their software is again vehicle spy. You can use that thing as well. It's a very costly in that case. There is a PickCan, very well-known tool around the world. Personally we use PickCan as well. Uh, these are the tools you can buy. It's cost around maybe 200 to $300, but in Indian rupees like 25 to 30,000. You can easily get it in the India as well. So these are the tools. So what exactly the software part works? So as we are hacker, right, we are cybersecurity guys, so we believe in the open source, right? So not buying the commercial tool. Buying commercial tool is good, definitely good, but that matters actually, right? There is aspect in the threat modeling, whether these tools are freely available to attack the perform attack on the canvas.
Mm.
Yes, freely available. You can see the can utils. The can utils is another kind of library, which is again the open source. And if you install on the Linux, again the Linux operating system is again open source, right? So you have to compile these things and you can start working on that can utils, and it does ton of things in that case. So what that particular can util supports, what kind of hardware tools. So on the left side you can see USB tin, CAN-TAC, CAN triple, value can, pick can. These are the hardware device can utilized over here with the help of can utils. There is another called as SavvyCAN. It's again the graphical user friendly software, which is you can utilize on the Windows platform as well as the Linux platform, and it's also support USB tin, CAN-TAC, ValueCAN, PickCAN. These are the things it's getting support. The best one I would say in that case, Carrying Caribou, very nice tool. If you don't have knowledge of automotive thing, it supports like a zero knowledge things actually. So zero knowledge tool, so nothing but like it's scripted in this very nicely, where the people come from the any cybersecurity background, they can understand easily that kind of thing. So it's I believe so we can call it as a metasploit for car hacking. So there are many in the Metasploit framework. There are many modules for CANBUS as well, where you can perform fuzzing attack, where you can perform UDS kind of attacks. You can perform on with the help of Metasploit. So carrying Caribou is, as per my understanding and things, is nothing but for me it's a Metasploit for the car hacking in that case. So carrying caribou can be used as a the great tool for many protocol. It supports many protocol in that case. Not exactly the many, the part, the subset of the protocol, such as like ISO-TP and then CANBUS, UDS, DOIP, many things it supports, XCP. So these are the protocols they support. What kind of hardware they support? It supports USB tin, CAN-TAC, CAN triple, value can, pick can. So it's very important information we are sharing over here. So there is another scripting or packet manipulation tool called as Skippy. Skippy is in cybersecurity is from long time. So Skippy, with the help of Skippy, you can craft your protocol or protocol stack in that case in such a way that we can create a protocol and send it. It's basically you can use for protocol fuzzing in that case, or rather you can say the communication fuzzing. So the Skippy, automotive Skippy, is dedicated to CANBUS. and dedicate to it. Supports a lot of protocols, which automotive protocols in that case, and it's very handy tool. If you know the Python very perfectly, and with the help of Skippy, you can design your own tool in that case. So I believe Skippy is one of the best. Automotive Skippy is one of the best libraries or framework for the CANBUS communication. And let's start the demo. So we are going to show you demo in two ways in that case. So like on the simulator and the on definitely on the uh, the cluster in that case, or the real one hardware. So Shiv, can I share the screen? Is it possible?
Yeah,
Yeah.
yeah, yeah. You should be
So
able to share.
okay, so let me start my VMware. Okay, you can ask. Till now, we are setting our the entire thing. So you can ask if you have any questions from audience.
Yeah, yeah. So there is one question which popped to my mind when you were mentioning about the software-based new connected vehicle tag. So I read that currently we are using the serial protocol-based CANBUS, but in the new
Mhm.
Tesla truck they have the full-fledged Ethernet connectivity.
Automotive
So
Ethernet,
yeah,
yes.
yes, automotive Ethernet. So what kind of is the protocol stack itself different, or it's still working on CANBUS?
Yes, absolutely. When we talk about the Ethernet, Ethernet nothing but talks about the kind of what we can say in that case, like TCP/IP in that case, right?
Yeah, yeah.
So it has the source IP address and destination IP address in that case. It's kind of the entire TCP.
Yeah,
So
yeah.
source and destination works on source and destination, then followed by the packets. So you can say all TCP IP kind of protocol attacks you can perform in the automotive Ethernet. It's nothing but the device they have, kind of device they have, or on the PCB board itself, they convert that protocol, particular stack actually in that case. So CAN bus to Ethernet, automotive Ethernet stack, they get changed. Kind of coupler, right? So
Yeah,
coupler change the entire like Modbus to any kind of Profibus or something. It's kind of things you can say the coupler in the automotive in that
yeah,
case. So definitely, if you attack on the Modbus communication, it's also reflected in the Profibus.
yeah, yeah.
That's how it
Absolutely.
is.
Yeah,
So let me check.
yeah. So there is one question while you are putting it up. Can we hack hardware remotely? Yeah.
Hardware remotely. Okay, so there are two ways to do that. There is something called as the. Uh, I'm just typing on the terminal as well. Meanwhile, I will discuss that
Yeah.
thing as well.
Sure.
So there is something called as hardware implant attack.
Mm-hmm.
So uh, if you know the communication, if you know the interface, uh, s- interface, or the interface pad,
Mm-hmm.
or connectors on the PCB board itself, if you attach any hardware that is acts as a hardware implant, you can communicate that through. Let's say example, you have something on the hardware like UART communication on the system itself,
Mm-hmm.
and you have another device which can, that particular device can be controllable wirelessly. Okay, and that particular device can attach on the target board, with the help of UART, right? And you can
Yeah.
perform ton of things. So UART, let's say it's not authenticated in that case. So you can easily get the access root shell in that case, or any kind of interface mechanism where you put all the communication, or inject that particular data through the UART. So that you can do. That means you can control the entire you know uh, communication or entire hardware itself.
Yeah. So it's basically putting, rather than having the software backdoor, you're putting the hardware backdoor, which
Yes,
is
yes, yes.
which is
Absolutely,
communicating. Yeah.
absolutely correct. So these are the this is the way. And another way, if they have remote communication, let's say they have the telematic unit, telco unit, or rather can say the telemetry device on that particular device itself. And if you compromise that telemetry device, that telemetry device can be in the automotive domain, locomotive domain, or any ICS in that case. So you can perform, you can, if you control that thing, so definitely you
Mhm.
can control the entire targeted device as well. That is the another way to do that. So two way, with the help of
Yeah.
hardware implant attack, and another is like if you have the vulnerability in telemetry device or anything, you can control that thing as well. Wait, any question?
No, there are no questions, but people are just saying thanks for putting this one on specifically on automotive security.
Okay.
Yeah.
Okay, so we have setup ready,
Mhm.
and config. Okay, and this is I'm going to share the screen soon.
Yeah.
The terminal. Okay, okay. So let's share the screen. Entire screen. Okay, is it visible? The entire screen.
Yeah, yeah, it's coming up.
Is it visible?
Yes, I need to put it on the share. Do you want to first? Yeah.
So, okay, a lot of people knows this very famous simulator over here.
Yeah. It's I see.
Uh, yeah, ICC. So it's perfectly visible, right? So you can
Yeah.
see the cluster over here.
Yeah.
This is speedometer, and the uh, CANBUS control. It's nothing but kind of controller over here. Okay, I'm jumping on that. I'm skipping the reverse engineering part because very time limitation is very low over
Yeah.
here.
Yeah.
So I try my best to explain in the within the time allocated time. Let's say I'm going to full screen, and let me see, is it visible?
Yeah, it's visible.
Yes, great. Okay, so we have the simulator over here. So one or two attacks we are going to perform over here. So if I press up arrow on the keyboard itself, so you can see the entire thing is getting increased, right? The speed getting increased. So if
Mm-hmm.
I do left, okay, you can go left. If I do right, oh, sorry, this is left, okay, and the right in that case, okay. So you can the open as well the entire door. So let's say right A. So right right shift A is for opening door,
Mm-hmm.
and B is another door, and X is a rear door, left rear door, and Y is left, uh, you know, ah, the Y is the right rear door. Okay, and if you want to, close that door, so shift left shift A, then B, X, and Y. So it closed the door. Okay,
Mm-hmm.
this is how the here what is communication is going from this ECU to this ECU. Let's say you have a cluster, and client give the simulator over here based out of the what we can say, the canoe they have, right? Canoe DBC file they have. Canoe vector canoe is another tool where you can use that particular device for hacking purpose or pen testing purpose as well. And basically it's this the entire vector canoe devices being used by developers in the automotive industry to simulate entire communication, and they understand the what communication is going on based on that. So that you can use over there, but definitely they give you the DPC file to simulate the entire environment. So this
Mm-hmm.
is our the targeted device we have, and they understand. Let's consider this thing is Canoe over here, and they're simulating entire. So how we can see the simulation? If you do CANDUM, and vcan 0 is the interface, so you'll see a lot of communication is going on here, right? So these are the communication. So let's see, let's say we can sniff the communication and try to understand what is the uh, right indicator identifier. So here, these are the IDs, right? You can see over here. These are the arbitration ID, and this is the data frame over here. So when you see 2 bytes over here, so DLC would be 2. Okay. If you see 5 bytes over here, that means DLC would be 5. So this is how the mechanism over here. Okay. So I click on the controller and I say right indicator. Okay, so if you see on the right side, something is added because the communication is going from CANBUS, CAN communication going from the controller to here. So if you see, let's say example, just demonstration purpose, only 183 to 189 in between something get added. So just concentrate over here. Okay, so so I click on the canvas controller panel and I'm pressing right arrow. So if you see 188 get added. So it's become 0 to 02. Okay. If I left arrow, so it become 0 to 01. So what is meaning? And DLC would be what? The 4 byte actually. So what here we understood. So 188 is the arbitration ID to control this one. Okay, and they are sending 4 bytes in that case. And first byte, if it is first byte 02, that means right, 01 is left. Okay, So right now we understood. We, let's say we'll have another terminal, and I'm going to jump on direct attack. So we can zero hyphen G. Let's say we want to send the 10 millisecond. Okay, and we have identified the ID, that is 188, and hyphen capital D is nothing but we have to data, right? So data 0200, that is second byte, 00 third byte, 00 fourth byte. So but we know that particular thing, like so 02 is for write, right? So let's say hyphen G, and what is the data? DLC, that is 4 byte, right? So hyphen V for more verbose mode, we need to understand what is going on in the communication. So we are sending data, and if you see, so we are sending, see the right indicator. So it's not fluctuating because we are sending the data at the rate of 10 millisecond. Okay, let's do 200 second. Okay, so now we can see it's fluctuating. So nothing but we performed the can injection attack in the in the can injection attack. We are performing fire hose attack. So we are sending data at the rate of 10 millisecond, 100 millisecond in that case. So let's see what happen if we send the 01. Okay, it's a left indicator, right? This is how we can first we can try to understand what data. So let's say I want to first the entire DLC. Okay, so hyphen D, that is small r, that is we are sending random data on the with DLC 4 in that case. Okay, so just sending random data, and then if you see over here, see the entire
Yeah.
indicators are blinking. So this is the real time attack you can perform in the car itself. Like, there are, I don't want to disclose the vendors over here, but yes, definitely Indian cars are vulnerable to do that actually. Some of the vendors, not every Indian car. Okay, Shiv, you can see that, right? The
Yeah, yeah,
entire is right.
yeah,
Okay,
yes. So this seems to be a replay attack, right? We are
it's
resending
not a
this.
replay attack. It's a can injection attack. It's not a
Okay.
replay attack. Okay, let's do the replay attack. Okay, you're
Yeah.
come to
Before
the
that,
point, right?
there is a question that is asked by Sanjeev. When
Okay.
there is an error detection mechanism available in CANBUS, then how the
Mhm.
injected message received and implemented by any node.
That is two way to put into the answer. Actually, it's depending on the developer, because they know how to calculate the entire errors, and
Mhm.
based on that way they can rectify. Another way, if they do not mitigate that thing, that turn into the bus of attack. So entire bus, two-wire communication goes down in that case. So it's called as bus of attack. So now, you know, we can perform that bus, a bus of attack. It creates bus of situation. And if you take that particular situation, so fuzzing, or rather sending those kind of, creating those kind of errors continuously, it's converted into, long time bus of attack. The entire communication get down. So these are the things actually, but in the developer point of view, they have to take what kind, how much they have to receive the errors, and based on that errors they have to mitigate that problem. That I can give you the overall, but this is very exhaustive topic. We can discuss. You can message me on the DM, so we can discuss. But because it's a huge topic in that case. But yes, these are the things you have to do, or the complications, or rather you can say the attacker can take advantage of that kind of thing. Actually, errors in that case.
There is a one more question by Poonam. What IC standard are followed in automotive? So I don't think there is a
Okay,
IC
ISO.
standard. There is ISO standard. Is it an IC or an ISO standard?
ISO standard. So in
Yeah.
automotive, there is called as ISO 21434,
Yeah.
and for India, they have. Please, I may be wrong, uh, depending on my memory. Actually, it's like 189 and 190. AIS 189 and 190 would be the cybersecurity standard for Indian government. The
Okay.
Indian, that is like ARAI. They released that thing still in draft mode, but yes, it's going to be mandated soon in future. And for ISO 21434, it's a worldwide accepted. There is R155, R156, UNCE standards are there. So
Mm-hmm.
it's depend on the the manufacturers, they where they want to launch their product, which area. So if the OEM want to launch their product, nothing but car and any kind of vehicle in Japan, they have to follow Japanese standards. I don't know the name of the Japanese standards, but if you Google, you will get it actually in that case. So it's very exhaustive, or rather, you can say there are many standards around based on the continental, I would say, in the term of the countries in that case. So let's say we are going to log the file because we want to perform replay attack. So this is thing, and let's say we are increasing the entire speed. Okay, push by pressing up arrow, and we are going right. Then we turn to left. Okay, and we stop somewhere and we try to open the door. Oh, sorry, right, shift A, then B, and then X and Y, and then our work done. Then I'm going to close the door. Left shift A, B, X, and Y. Okay, Y. Okay, that thing closed, right? So we perform all regular things on the cluster itself, and just we pressing Control C. If you see, this is the log file we have, right? Okay, let's say there is code tool called as can player, and we don't need to mention the interface over here because the can dump. Let's say what exactly the can dump. Okay, cat can dump. This is the logs. If you see, these are the logs actually. If you see here, they mention the interface itself. So that's why we don't need to mention interface with the can player. Okay, and can dump. Okay, we are just running hyphen I. Okay, hyphen capital I. Okay, and now we are running the entire log file as a replay attack, and you can see over here, so the needle getting fluctuating because it's also sending 0 kilometers left and right. That's why it's needles getting
Mm-hmm.
fluctuating. And we are going to open the door. I hope it shows. Yes, open the door.
Yeah.
Okay, this is the replay attack you can perform. Whatever you see over here and whatever we are using the data of the tools over here, you can use same tools on the ECU or on the vehicle level itself. Okay, so we done. Okay, we played now. Okay, see, so the entire log file done. Okay, this is how you can perform replay attack. Okay, so I'm going to show you on the I'm going to show you on the real device as well. Okay, so let me let me share my camera. Let okay. I stop my this thing and let me share. Okay, virtual no, and then this is my lab actually,
Okay.
and video. Okay, okay. Is it visible?
Yes, it is.
Okay. So this is the cluster. Okay.
Mhm.
You can see here the commands as well. So let me fire here. Let me check. Okay. Okay. So we are going to use this one. The this tool. Oh, USB tin. Okay.
Mhm. Mhm.
And we have cluster over here. So this is cluster. This is the harness. Harness nothing but wires, and we identified can high and can low wire. Okay, and this tool have a can high can low over here, and this thing is connected the can high can low wire as well. So we are using this wire USB micro USB to type A B type A USB. Okay, so I'm connecting over here, and this thing is going to connect with my laptop. So in the laptop, so I don't know whether it is visible. I hope it's something should be visible over here. So if I connect ls, okay, let's say ls USB over here, and this is the ls USB where the microchip emulator demo something, the microchip technology, that particular IC we are using here. So I want to attack directly, nothing but we are doing fuzzing attack on the entire things actually. So before that, I need to set up the USB tin in the Linux machine itself. So if I search kind of on the Google USB tin and Linux, so it will navigate to first URL. If you go to first URL, so you will see how to set up these things, the USB tin. Okay, so 1, 2, 3, 4, and then raw, and then SL can. Let's SL can, and then mm, we need to okay. Let's TTY. It's ACM0. Its port is allocated to that particular thing, and S6 over here, and this device, that particular USB tin going to attach with that particular uh, USB tin. So we are going to up the CAN interface. So if you do if config, you will see SLCAN 0. Shiv, is it possible I can share the screen and the video at the same time? Is it possible that?
Yeah, that should be possible.
So can I share the
Yes.
screen?
Yes.
So you can see the screen and the camera, right?
Yeah, I need to enable that. And now should be.
You can see hand in the camera, and the we are on the terminal. I'm I'm typing. Okay, I think so. Two screen now, right? Okay. Okay, so can gen. Okay, if I do if config, so this is virtual can. We did it on the simulator. Okay, let me close that simulator. Okay, we have SLCAN 0. So as I said, this chipset is use SLCAN interface. So works on SLCAN. So if I do CAN SLCAN 0, you'll see some communications getting triggered from the this cluster actually. Okay, so Control C, and if I do CAN sniffer SLCAN 0 and hyphen C. So you'll see those are the IDs getting floated over here. And then these are the communications getting here. But honestly, we don't know the simulator. We don't have a simulator over here, right? They give just only the instrument cluster. So how we can perform fuzzing over here. So this is the last demo we are going to do actually. SLCAN 0, I said hyphen G, and let's say 100 millisecond, okay, hyphen capital I, and we give incremental value, and hyphen D, again, it would be a random value, and hyphen L, capital L, we are mentioning the 8 byte over here, hyphen V, and hyphen V. So let's see, save, so you can see the changes. Should work. It's really slow, right? We'll make it on the 10. So will be, see,
Yeah.
so we are fuzzing. So you can see the indicators and everything, and too many things over here. Sure, you can see, right?
Yeah, I can see it. I think, yeah, this is quite visible, and the milometers are moving. The
Yes. Yes.
instrument cluster is visible now.
Okay. Just we'll wait for a few seconds. Yes. So you can hear the some beeps, right?
Mhm.
Yes, these are the things you can perform. This is kind of fuzzing over here. So if you know the scripting, Python scripting, you can minimize the thing, and simultaneously you can use scan sniffer, and you try to find out those IDs as well. So there are many ways to do that. So in that case, we found a lot of vulnerabilities in that case. Kind of fire hose attack you can perform. You identify exact. You will find exact ID with exact data, which can be reverse engineered, and we can find the exact data as well. So with the help of reverse engineering, and you can perform. These are nothing but kind of CANBUS injection attack, and followed by the sub attacks called as fuzzing, virus attack. There could be a possibility that you're sending a different kind of DLC, minimum DLC, maximum DLC, which is allocated by the developer itself, right? In that case, We perform many things as per who uh, come up with the Secuity implementation. Secuity is nothing but like they are going to secure the entire CANBUS communication. We still found the vulnerability in that case. So there are many ways. You have to think out of the box and come up with
Mhm.
those idea. Actually, there's this nothing but attack. It's kind of CANBUS attack over here, and the same way you can perform on CAN-FD and the other protocols as well
Yeah,
in
this
this
is
case.
quite
uh,
this is quite educational actually to see these things actually happening. And I think the industry is moving towards more regularized environment, and these things needs to be tested well, because vehicles are moving and the safety is the prime importance. So all these testings are part of that journey that we have to traverse to reach to their secure systems basically. And this is like, yeah, one of the systems that are not designed with security in the mind but functionality over there. And I think the purpose of this session is to give the insights that these kind of things are possible in the traditional systems, but we are moving towards more robust technology. When we have this ethernet connected systems available, then we have the scope of implementing more compute power and more uh, security as a layer over it, right? So yeah, that's the whole message. We don't endorse any kind of hacking activity. Of course, this is for educational purpose.
yeah, I actually I'm really sorry I could not hear properly that thing, but I understood some words that you guys you're talking about the security and the canvas
Yeah,
and the demo part actually.
yeah.
uh, yes.
Yeah, so there are bunch of questions about that this fluctuation affect the real speed or just a speedometer.
Okay, did this fluctuation affect the real speed or just speedometer? So this is depending on the functionality which is made in the uh, smart card itself. So the
Yeah,
entire let's say your that would be a possibility that I may be wrong in that case. Right now, in the current scenario, whatever you see the vehicle itself over here, you cannot control that thing. Only the speedometer is going up and there actually.
yeah,
But if you're attacking on autonomous vehicle, which is automatically get control, so there would be possibility you can control steering and speed. That is true at
yeah,
all. So it's depending on the how smart your car it is.
okay. Yeah, I think we had a really good engaging discussion, and this is quite technical stuff as well, and you covered the entire gamut of the canvas aspect, the connected vehicle side, and also demoed a bunch of attack and scenarios that are possible. To me, it was a new thing. Of course, I learned a lot in terms of the protocol stack and the possibilities of connecting to the vehicle, and then playing around with these traditional connected car systems and the ECUs. So thanks, Arun. Thanks for taking time. We slightly overshoot, but yeah, it is obvious that it is your passion to do demos on automotive security, and I really found that excitement when you do the demos. So thank you. Thanks again for taking time out, and uh, I look forward to more such discussions in the future.
Sure, sure, definitely. So there are
Yeah,
many attack vectors and many attack surfaces as part of cybersecurity aspect. Definitely,
yeah,
will in future we will cover that thing as well.
yeah. Okay, with that, I think we are good to close for the day. Thanks, everyone. Thanks for joining this. And if you have any further questions, you can reach out to Arun or me. Uh, we thank you for joining this, and have a very good rest of your evening. Thank you.
Yes, yes. Thank you so much, guys, and thank you very much, Shiv and OT Hurdle, to having me over here. and that
It's
is
a
the best part over here in the pro of the OT hurdle actually, which launched many great session about the OT and the automotive nowadays, and I'm really happy over here to be.
thank you. Thanks again, Arun. It's a privilege to have you.
Yeah, thank you so much.